really intriguing question. How many squares are exactly 4 greater than a prime? So when we know there's going to be a finite value here between 0 and 4, but if we didn't know that and we were investigating this, then, you might say, well, maybe there's an infinite number and so on. And how do we know there's not an infinite number? Well, what you should do in all these sorts of situations is just maybe write down a few square numbers and see what answers there are. So first few square numbers, 1, 4, 9, 16, 25, 36, 49. And then I'm interested in the numbers that are 4 less than that because it's how the squares are exactly 4 greater than a prime. So I need to subtract 4. So minus 3, 0, 5, 12, 21, 32, 45. So how many squares are exactly 4 greater than a prime? I'm interested in whether this is a prime number or not. It's clearly not and not. This one is. Okay, so I've definitely got an answer of 1. However, 12 is not, 21 is not, and you might be tempted now to say, well, yeah, okay, it's just going to be 1. But how do we know it stops? That's getting back to my original question. And this is where actually it's best to think about it algebraically. So let's, instead of writing 1 or 4, which is 2 squared or 3 squared or 4 squared, let's write it as n squared. And instead of minusing 4 from 9 and getting 5, I'm going to minus 4 from it. And this is what we can then realize. This is a difference of 2 squares. I can factorize it to n plus 2, n minus 2. That means it has 2 factors. The only way this can be prime is if one of these is equal to 1, because a prime number is itself times 1. Now, I can't have that this one is 1 and this one's something else, because this is less. So it must be that this is equal to 1 if it's going to work. And at this point, I can see like there can only be one answer to this. It's going to be 1. Let's just follow through and see, though. It's going to be when n minus 2 is equal to 1, so therefore n is equal to 3. And from that, I can substitute in and see that it's going to be 9 minus 4, which is 5. So that's pretty cool, I think. A nice little algebraic proof to show it. Um, and actually, it's going to be the same situation. How many squares are exactly 9 greater than a prime? It's just going to be the 1, because you can write that as n squared minus 9, and then you can factorize it. So really neat that you can like rule out numbers in this way. I'm not sure it's actually going to be useful, but it's an interesting fact, I think. Same with how many squares are exactly 1 greater than a prime? In fact, there's only going to be 1, which is 2, because then when you get n squared minus 1, you can write it as n plus 1, n minus 1. So if you know your square numbers, then you also know that most of the numbers below them are not going to be prime. 81, 100, and let's think of an awkward one. 21. I can't really think of an easy, difficult one right now, but like 1,000 squared. Okay, if I minus 1 from it, then it can't be prime. That's what I'm trying to get at here. So a nice result.